All right, so we'll distribute the negative 7 over first. So it's going to be 28 minus 7i. Right, and then we'll take the I and distribute that over. So I times negative 4 is negative 4i. I times I is plus I squared. All right, now we can combine like terms in the middle. Okay, and then we can change I squared to negative 1. So 28 minus 11i minus 1. And then we can combine like terms. And then we're going to always write our answers in standard form. So again, standard form is a plus bi. So we want the real number to come first, the imaginary number to come second. So 28 minus 1 is 27, and then minus 11. All right, now number 12 says 7 plus 6i all squared. So remember, anytime we see a polynomial being squared, we want to write it twice. 7 plus 6i times 7 plus 6i. And then we'll go ahead and distribute. So 49 plus 42i plus 42i plus 36i squared. All right, now we'll simplify. So we have like terms in the middle that we can combine, and then 36i squared is going to really change to negative 36 because I squared is negative 1 times 36 becomes negative 36. So 49 plus 84i minus 36. Right, combine like terms. All right, so again, I'll just so you can see it. All right, so 49 minus 36 is 13 plus 84i. Yes? 7 times 6. So 7 times 6i is 42i. All right, so go ahead and do 13 and 14. That's it. All right, so on 14, the i's in the middle are going to cancel out, and that's because these are special complex numbers. They're exactly the same term, just opposite signs. So when that happens, the i's are all going to end up canceling out. All right, so go ahead and do 15 and 16 now. All right, so on 15, this minus I squared is going to change to plus 1 because I squared is negative 1 times the negative changes to plus 1. All right, so a conjugate is has the same terms, uh, but opposite. All right, so they have the same terms, just opposite signs of the imaginary number. All right, so like 14, 15, and 16, those are called conjugates. Okay, they're special complex numbers. So we see them as far as conjugates go. A plus bi, its conjugate is a minus bi. All right, and then the conjugate of a minus bi is a plus bi. All right, so all we do is change the sign of the imaginary number part, and we get what's called a conjugate. So you can see what happens on 14, 15, and 16 when we multiply conjugates together, the imaginary stuff goes away. And all we're left is just a number without an I in it. All right, so for 17, 18, and 19, we're going to list out or create the conjugate of each of these terms. Okay, so each of these complex numbers. So the conjugate of 4 minus 2i is going to be 4 plus 2i. All right, so again, we just changed the sign of the imaginary part. The real number stays exactly the same. All right, 18, the conjugate of negative 3 plus 5i is going to be negative 3 minus 5i. All right, and then 19, the conjugate of 3i is going to be negative 3i. All right, now conjugates are important for division. All right, so when we want to divide complex numbers, the idea is to get rid of the I off the denominator. So just like with radicals, you can't have radicals in the denominator. Well, with complex numbers, we can't have I in the denominator. So the trick here is to get rid of the I is to multiply top and bottom by the conjugate of the denominator. Okay, so it's always the conjugate of the denominator. So the conjugate of 4 plus I is going to be 4 minus I. So we're going to multiply top and bottom by 4 minus I. Now, it's going to help to put parentheses around all this stuff because you're double distributing the top and the bottom. And so if you put parentheses in there, it's just going to keep it a little bit more organized for you. All right, so multiplying the top. Okay, I'll do the top first. 2 times 4 is 8. 2 times negative I is negative 2I. Negative 3I times 4 is negative 12I. Negative 3I times negative I is positive 3I squared. We'll simplify that in a minute. Let's go ahead and multiply the bottom now. Now, if you get good with this conjugate stuff, you'll see the denominator is going to go pretty quick as far as multiplying. All right, so 4 times 4 is 16. 4 times negative I is negative 4I. I times 4 is plus 4i, and I times negative I is negative I squared. So now we just have to clean this up, simplify it. All right, on the bottom, I can see negative 4i plus 4i. Those are going to cancel out. The negative I squared at the end, that's just going to change to plus 1, which I can then add to 16, and I get 17 on the bottom. All right, so now there's no I in the denominator. I got rid of it. Now I just have to simplify the top. All right, plus 3i squared at the end, that's just going to change to minus 3, which then I can add to the 8. 8 minus 3, that's going to give me 5. And then the negative 2i minus 12i in the middle, I can combine those together. That's negative 14. All right, so you'll see this before you do it. As far as the denominators, when you're multiplying the conjugates together, there's shortcuts on the conjugate. All right. So the bottom, you can square the first number. That gives you the first number. You square the last number, okay, and or multiply the I times negative I. That gives you your negative I squared, which is then just change to plus 1. The middle term is going to cancel out. Okay, so multiply the first term together, multiply the last term together. That's really all you need for the bottom. And then you just simplify from there. All right, so number 20. The conjugate is going to be 2 plus 4i. All right, so we'll multiply across. So on top, there's just 3i being multiplied to 2 plus 4i. So all we have to do is take 3i and distribute that in. So 3i times 2 is 6i. 3i times 4i is plus 12i squared. On the bottom, since we're multiplying conjugates together, we multiply the first terms together, that's 4. Multiply the last terms together, that's minus 16i squared. Again, the middle terms are going to end up canceling out because they're conjugates. All right, so now we just have to simplify this. Let's see, on top, 12i squared is really negative 12, so I'm going to put that first. Plus 6i, second. On the bottom, minus 16i squared is really plus 16, plus 4 is 20. Now there is one last step that you always have to check once you get it down to these three terms, is you want to see, is there a number that will divide into all three terms? If there's a number that will go into all of them, then you have to divide it. And that's just simple. It's just like simplifying fractions. Okay? But you have to have three numbers to do this. All right, so you can see here there was nothing going to go into 5, 14, 17. So that's simplified. But this one, what's the biggest number that will go into all three of them? 2, right? I can divide them all by 2. So I'm going to divide each of those by 2 to simplify the fraction down. So it's going to be negative 6 plus 3i all over 10. So that's the simplified answer. All right, let's skip 21, but I want to do 22 and 23. All right, so 22, the conjugate of 3i is negative 3i. All right, so multiplying across, 2 times negative 3i is negative 6i. On the bottom, 3i times negative 3i is negative 9i squared. All right, so I squared is negative 1 times negative 9 changes to a plus 9 on the bottom. Now, negative 6i over 9, this is just a simple fraction. Okay, so I can simplify this fraction down. I divide top and bottom by 3. So negative 2i over 3 is the answer. All right, and let's do this last one, 23. All right, so the conjugate of 2i is negative 2i. We want to put that negative 2 plus 5i. It just helps to put it in parentheses. So here on top, we're going to distribute. You can think of it as backwards. The negative 2i is getting distributed. All right, negative 2i times negative 2 is positive 4i. Negative 2i times 5i is minus 10i squared. On the bottom, 2i times negative 2i is negative 4i squared. All right, so now we're just going to simplify this, clean it up a little bit. All right, on top, I squared, again, is negative 1 times negative 10 is positive 10. So 10 plus 4i on top. On the bottom, negative 4i squared is really positive 4. All right, so now I want to see if there's a number that I can divide all three numbers by. And I can divide them all by 2. So then I'm going to get 5 plus 2i all over 2.